Hello and welcome. It is December 12th, 2025. If you have been following the headlines, you know that the night sky is currently playing host to a riddle that has astronomers, astrophysicists, and frankly, anyone with a telescope completely baffled. We are talking, of course, about 3I Atlas, also designated C2025N1. This is our third interstellar visitor, following the now legendary Oumuamua in 2017 and the rogue comet 2I Borisov in 2019. But if you thought those two were strange, 3I Atlas is rewriting the rulebook in real time. We are not just looking at a rock moving fast, we are looking at an object that is changing its fundamental appearance, its color, in a sequence that seems almost too structured to be random. From a deep, dusty red to a toxic green. And now, as we approach its closest encounter with Earth, a brilliant, bursting blue. These aren't just optical illusions or tricks of the light. These are chemical fingerprints, and they are telling us a story that science is struggling to translate. Today, we are going to break this down, step by step, stripping away the hype to look at the raw physics of what might be the anomaly of the century. Let's go back to the beginning. The date was July 1st, 2025. The Atlas system in Chile, the Asteroid Terrestrial Impact Last Alert System, picked up a faint, fast-moving point of light. At first glance, it looked like business as usual. The trajectory was hyperbolic, meaning it wasn't bound to our sun. It came from deep space, fell into our gravity well, and was destined to leave just as quickly. But as telescopes around the world swung to track it, the first anomaly appeared immediately. It wasn't the shape or the speed, but the color. The object was red, deep red. In the astronomical community, we call this alien rust. Now, before we get too carried away, red is actually a fairly typical color for objects that have spent billions of years drifting in the void between stars. When you have a surface covered in simple organic compounds, carbon-based molecules, and you bombard them with high-energy cosmic rays for eons, they undergo a process called space weathering. The chemical bonds break and reform, creating complex tar-like substances known as tholins. Tholins are dark and reddish. We see this in our own solar system. Look at Arakoth, the object visited by New Horizons, or even some of the Trojan asteroids around Jupiter. They are red because they are old, cold, and covered in this cosmic soot. So, when 3I Atlas first appeared as a reddish dot, the initial sigh of relief from the scientific community was audible. It looked like two Borisov. It looked natural. It looked like a dirty snowball from another star system. But then, we started getting the spectroscopy numbers. Let's look closer at the data. When we analyze the light reflecting off an object, we can determine what it's made of. The spectra from 3I Atlas showed intense light scattering in the 600 to 700 nanometer range. That is the red part of the spectrum. But it wasn't just reflecting red light. It was absorbing blue light with an efficiency that was startling. This suggests a surface that is incredibly rich in these organic tholins, perhaps more so than anything we have seen before. It was a rusty lump, tumbling through the dark. However, the comparison to Oumuamua is where things get interesting. Remember Oumuamua? That long, cigar-shaped object was weird because it was tumbling and accelerating, but visually it was somewhat dull. It varied in brightness, but its color was a muted, reddish-white. 3I Atlas was different. The red was vibrant, almost saturated. And there was something else, polarization. Light waves vibrate in different directions. When sunlight hits a surface, it bounces off, and depending on the texture of that surface, the light waves align. They become polarized. The light coming from 3I Atlas showed negative polarization at angles that we usually associate with metals or extremely dense, non-porous structures. This wasn't just a fluffy ball of dust. This was something hard, something solid. If you are enjoying this deep dive into the physics of the unknown, and you want to stay updated as we track 3I Atlas through its December approach, make sure you hit that subscribe button. We are tracking this story day by day, and you won't want to miss the analysis of the new data coming in next week. Now, back to the alien rust. The real anomaly of this phase, the thing that kept researchers up at night in July and August, was the persistence of the color. Typically, as a comet approaches the sun, it warms up. The ices on the surface, water, carbon monoxide, carbon dioxide, begin to sublimate. They turn from solid to gas, blasting off the surface and carrying dust with them. This creates the coma, the fuzzy atmosphere around the comet. Usually, this process dilutes the surface color. The bright white light of the scattering dust and gas washes out the deep red of the surface tholins. We expected 3I Atlas to fade, to turn a dusty gray or white as it got closer to Mars's orbit. It didn't. For 2 solid months, even as it accelerated towards the inner solar system, that red signature remained rock steady. It was as if the object wasn't sublimating in the way a normal comet should. The rust wasn't just a surface coating. It seemed to be intrinsic to the material being ejected, or perhaps the surface wasn't ejecting much material at all yet. This behavior defied the standard cometary models. If it was a ball of ice, the ice should be vaporizing. If it was a rock, it shouldn't be this red. The negative polarization hinted at metallic inclusions, tiny grains of iron or nickel mixed into the matrix, which could explain the optical properties, but metals don't sublime at these distances. We were looking at a paradox, a red object that refused to act like a comet, yet moved too fast to be an asteroid. By late August, the debate was heating up. One camp argued for a supercrust, a layer of organic material so thick and baked on that it was insulating the ices below, preventing the usual outgassing that would wash out the color. Another camp, the more speculative one, began to whisper about artificial materials. Could a protective coating designed to shield a probe from interstellar dust impacts look like tholins under a spectrometer? It's a stretch, absolutely. But in science, you have to fit the theory to the data, not the other way around. And the data was screaming that this rust was not behaving like natural space dust. As August turned to September, the object crossed the frost line, the distance from the sun, where water ice begins to sublime in vacuum. We were ready for the red to finally fade, for the familiar white coma of a comet to emerge. We had our telescopes calibrated for dust. We were watching for the whitewash. But the universe, it seems, has a sense of humor, or a sense of drama. Because 3I Atlas didn't turn white, it didn't stay red. As the heat penetrated that mysterious crust, the chemistry shifted violently. The red vanished almost overnight, replaced by a glow that shouldn't exist in that quantity at that distance. The object didn't just wake up. It changed its skin entirely. We were done with the alien rust. We were about to enter the era of the green poison, And if the red phase was a puzzle, the green phase was a warning. The stability of that red phase, the sheer stubbornness of that spectral signature, set the stage for everything that followed. It established a baseline of weirdness that 3-Eye Atlas has adhered to ever since. It told us that we weren't dealing with a standard ball of dirty ice. We were dealing with something that reacts to its environment in stages, almost like a program executing a sequence of commands. First, shield the interior. Second, well, we'll get to the second phase in a moment. But it is crucial to remember, the red wasn't just a color, it was a shield. And when that shield finally breached, what came out wasn't water. It was something much more exotic and much more baffling. This brings us to the end of the first chapter of our investigation. We have an object from deep space moving at impossible speeds, wearing a disguise of deep red organic armor that refuses to behave like natural dust. It fooled us into thinking it was just another Borisov. But as it crossed the orbit of Mars, the disguise began to crack. The red faded, not into the white of water vapor, but into a brilliant, eerie emerald. The alien rust was gone. The poison had arrived. And, as we will see, this wasn't just a change in hue. It was a complete metamorphosis of the object's chemical output, challenging our understanding of what can form in the dark nurseries of other stars. Proceeding to the next file, we will analyze this green shift. We will look at why nickel, a heavy metal, was suddenly being spewed into space in quantities that make no sense, and why the tail of this comet decided to point in the wrong direction. The mystery of 3-Eye Atlas was just getting started. As we established in our analysis of the alien rust phase, 3-Eye Atlas was already behaving strangely before it even crossed the orbit of Mars. The persistence of its red spectrum suggested a surface that was stubbornly resistant to the sun's heat. But as September 2025 rolled around, the object began to plunge deeper into the solar gravity well, racing toward its perihelion, its closest approach to the sun, scheduled for late October. The heat was rising. The crust, whatever it was made of, could no longer hold back the pressure building inside. And then the dam broke. Between early September and November, the object underwent a transformation that was as beautiful as it was unsettling. The deep, dusty red vanished, replaced almost violently by a brilliant, piercing green glow. Now, green comets are not unheard of. We have seen them before. The green comet, C 2022 E3 ZTF, that passed us a couple of years ago, is a prime example. But the green of 3-Eye Atlas was different. It was intense, concentrated, and chemically baffling. To understand why, we have to look at the chemistry. In a standard comet, a green hue usually comes from two specific molecules: diatomic carbon, C2, and cyanogen, Cn. When sunlight hits the frozen nucleus of a comet, it sublimates these molecules into the coma, the cloud of gas surrounding the solid core. Ultraviolet radiation from the sun then bombards these molecules, exciting their electrons. When those electrons drop back down to a lower energy state, they emit photons. For C2 and Cn, those photons happen to be in the green part of the visible spectrum, around 500 to 550 nanometers. This is fluorescence, the same process that makes a highlighter pen glow under a blacklight. So, seeing green wasn't the anomaly. The anomaly was where and how much green we were seeing. This contradicts what we previously thought about the composition of interstellar objects. Typically, these visitors are dominated by water ice, carbon monoxide, and dust. C2 and Cn are usually trace elements, the seasoning on the cosmic snowball. But for 3I Atlas, the spectral lines for these compounds were off the charts. The signal was so strong, it saturated the sensors on some of our ground-based telescopes. It was as if the object wasn't just releasing these gases, it was made of them. The coma wasn't a mix of dust and gas. It was a cloud of pure, glowing cyanide and carbon vapor. But the real shock came when astronomers looked deeper into the spectra, searching for the fingerprints of heavier elements. Buried in that green glare, they found the unmistakable signature of nickel. Nickel is a metal. It is heavy. It has a high melting point. To vaporize nickel, you usually need temperatures far higher than what a comet experiences at 1.5 astronomical units, AU, from the Sun. Yet there it was, ionized nickel, floating in the coma, glowing alongside the cyanide. We have seen nickel vapor in comets before, but usually only when they are practically skimming the surface of the Sun. 3I Atlas was still further out than Earth when this started. The presence of such heavy metal vapor at such a distance implies a chemistry we simply don't have a model for. It suggests that the nickel wasn't just a rock inside the comet. It was likely part of an organometallic compound that sublimates at lower temperatures. Or, if you want to entertain the artificial hypothesis, it looks suspiciously like the breakdown of complex alloys or machinery. The green poison phase wasn't just about chemistry, though. It was about structure. As the object approached perihelion on October 29th, a new feature emerged, an anti-tail. Now, cometary tails are complex. You usually have two: the dust tail, which curves along the comet's path, and the ion tail, which points straight away from the Sun, pushed by the solar wind. An anti-tail is an optical illusion that appears when Earth crosses the plane of the comet's orbit, making it look like a spike is pointing toward the Sun. It's usually a short-lived trick of perspective. For 3I Atlas, the anti-tail appeared, but it didn't behave like an illusion. It was sharp, defined, and it glowed with that same toxic green hue. And here is the kicker. It stayed fixed. As the viewing geometry changed, the anti-tail should have rotated or disappeared. It didn't. It remained pointing sunward, defying the solar wind that should have been blowing those light C2 and Cn molecules backward. This is where the physics gets messy. Neutral gas molecules like C2 aren't affected by magnetic fields, but they are affected by solar radiation pressure. They should be pushed back. The fact that a structure of glowing gas persisted in pointing toward the Sun suggests one of two things. Either the gas was being ejected with such high velocity in that specific direction that it overcame the solar wind, a jet of immense power, or the material wasn't gas at all, but something heavier, perhaps dust grains coated in that fluorescing material, heavy enough to resist the push of sunlight. The industrial speculation ran wild during this phase. Nickel and cyanides are not a stable couple in the vacuum of space without a constant source. They react, they break down. To have a sustained, high-intensity glow of these specific elements for 2 months suggests a reservoir of material that is incredibly pure. Astronomers noted that the spectral profile looked less like a dirty snowball and more like the exhaust plume of a chemical reaction. The term camouflage started appearing in non-public discussions. If you wanted to hide a probe, wrapping it in a cloud of ionized gas is a great way to scatter radar and confuse visual sensors. But if this was camouflage, it was failing. The green was a beacon shouting across the solar system that something unusual was happening. And then, just as we thought we had a handle on the green poison, the universe threw another curveball. The green didn't fade as the object moved away from the sun after perihelion. Standard models predicted that as the temperature dropped, the sublimation of these specific gases would slow down. The green should have dimmed, returning the object to a darker state. It didn't. Instead, the green intensity held, right up until the moment it didn't. The transition wasn't gradual, it was a snap. 1 week, the object was a toxic emerald smear in the sky. The next, the green was being swallowed by a new, even more energetic color. The poison phase was ending, not with a whimper, but with a bang. The chemistry was shifting again, moving from the heavy, complex molecules of the green phase to something lighter, faster, and infinitely more energetic. We were about to enter the blue burst. Building on this, we have to ask ourselves, what kind of natural object sheds its skin in such discrete, quantized stages? First, a shield of red dust, then a cloud of green cyanide and nickel, and next, as we will see, an explosion of blue ions that would defy gravity itself. The narrative of 3I Atlas was moving from weird comet to impossible physics. The green phase showed us that the object had a complex internal composition. The blue phase would show us that it had an engine. Proceeding to the next file, we will dive into the blue enigma, analyzing the sudden dominance of the ion tail, the lack of water, and the non-gravitational acceleration that has turned this from a curiosity into a potential warning. The green poison was just the fuel. The blue burst was the ignition. The transition from green to blue wasn't a fade. It was a detonation. As 3I Atlas swung around the sun in late October and began its outbound journey, heading for a close encounter with Earth on December 19th, the green poison that had defined its perihelion passage suddenly collapsed. In its place, a brilliant, electric blue luminosity took over, dominating the spectrum between 400 and 500 nanometers. This wasn't the subtle blue hue of a distant ion tail. This was a blue burst, a sudden surge in brightness that made the object visible to even modest amateur telescopes. We are now in the current phase of the phenomenon, the blue enigma, and this is where the physics goes from unusual to unprecedented. Why blue? In standard cometary physics, blue light comes from ions, atoms or molecules that have lost an electron and become electrically charged. The most common culprit is ionized carbon monoxide, CO+, or sometimes ionized water, H2O+. These ions are picked up by the solar wind, the stream of charged particles flowing out from the sun, and are pushed directly away from the star, forming the straight, narrow ion tail that comets are famous for. But for 3I Atlas, the blue wasn't confined to the tail. It flooded the coma. The entire head of the comet began to glow with this ionization signature. This implies a massive release of gas, a sudden outgassing event that dwarfed anything we saw during the green phase. The object was shedding mass at an incredible rate. Here is the crucial detail. The spectral analysis of this blue light revealed a shocking lack of water. Comets are supposed to be dirty snowballs. Water ice is their primary ingredient. When they get close to the sun, that water sublimates, creating the bulk of the gas we see. But the spectra from 3I Atlas showed almost no hydroxyl OH lines, which are the telltale sign of breaking down water molecules. Instead, the blue glow was dominated by carbon dioxide, CO2, and carbon monoxide, CO ions. This object is dry. It is incredibly volatile, rich in carbon, but almost completely devoid of the one thing that defines a comet. This dryness aligns with the earlier alien rust and green poison phases. A surface of organic tholins, red, and a subsurface of cyanides and nickel, green, suggests a formation history in a carbon-rich, oxygen-poor environment. Perhaps the outer disk of a dying carbon star, or a region of the galaxy with a completely different chemical makeup than our own. But the chemistry is just the setup. The punchline is the movement. As this blue gas exploded outward, 3I Atlas did something that made orbital dynamicists drop their coffee mugs. It accelerated. Now, comets do accelerate. It's called non-gravitational acceleration. As gas jets erupt from the surface, they act like thrusters, pushing the comet nucleus in the opposite direction. We saw this with Oumuamua. It had a slight push that couldn't be explained by gravity alone. But Oumuamua's push was gentle, a subtle drift. The push on 3I Atlas was a kick. Coinciding perfectly with the shift to blue, the object's trajectory deviated sharply from the predicted gravitational path. The force required to produce this deviation implies a mass loss rate that is staggering. If this is natural outgassing, the object should be tearing itself apart. The sheer volume of gas needed to generate this thrust would usually disintegrate a small cometary nucleus. Yet, images from the Hubble and James Webb Space Telescopes show a coherent point source. The nucleus is intact. It is spewing gas like a rocket engine, but it isn't crumbling. This mismatch between the thrust and the structural integrity is what fuels the blue engine hypothesis. If you were to design a solar sail or a propulsion system that utilizes solar heating to expand a propellant, it might look exactly like this: a sudden controlled release of volatile gas at perihelion to maximize the gravity assist. The fact that this burn happened after the closest approach to the sun, adding velocity for the exit trajectory, is exactly how you would pilot a spacecraft leaving a system. I want to pause here and ask you a question. We are looking at an object that changes color in a sequence, contains rare industrial metals, lacks water, and is currently accelerating under its own power. Do you think this is just a wild natural comet? Or are we looking at the exhaust plume of something artificial? Let me know your thoughts in the comments below. The line between anomaly and technology is getting blurrier by the day. The blue burst also brought with it a change in the tail structure. Remember the fixed green anti-tail? As the blue took over, the tail structure became chaotic. We started seeing disconnection events, where the tail snaps off and reforms, happening rapidly. This indicates a turbulent interaction with the solar wind, or perhaps a magnetic field generated by the object itself. Some readings suggest a localized magnetic anomaly around the nucleus, which would be impossible for a chunk of ice and rock. A magnetic field would protect the ions from being stripped away too quickly, allowing the blue glow to build up to the intensity we are seeing. So, We have a dry, carbon-rich object that waited until it passed the Sun to fire its main thrusters, turning a brilliant blue in the process. It is currently rushing towards Earth's orbital plane, moving faster than gravity says it should. The blue enigma is not just a pretty light show. It is evidence of a powerful physical process that we do not fully understand. This connects to the final piece of the puzzle. We have seen the red shield, the green reactor, and now the blue engine. Each phase has been distinct, separated by sharp transitions. Nature is rarely this organized. Natural processes are messy, they blend and fade. 3i Atlas operates in steps. As we prepare for the final chapter of this saga, the question isn't just what is it, but what is it doing? The sequence of colors, red, green, blue, is the primary colors of light. It is a sequence that feels constructed. And, as we will explore next, the probability of a random rock stumbling through this exact specific chemical sequence is vanishingly small. We are looking at the impossible sequence, and the implications are terrifying. Proceeding to the next file, we will synthesize this data. We will look at why the red-green-blue progression is the smoking gun for the artificial hypothesis, and why the scientific community is split down the middle as we approach the December 19th encounter. The show is almost over, but the finale promises to be blinding. We have analyzed the alien rust, the green poison, and the blue engine as separate events. But to truly understand the magnitude of what is happening with 3i Atlas, we have to stop looking at the frames and start watching the movie. We have to look at the sequence, red, green, blue. In the chaotic, violent environment of the inner solar system, comets are messy. They are unpredictable. They outburst, they fragment, they fade, but they rarely follow a script. 3i Atlas has followed a script so precise that it feels less like geology and more like choreography. Let's recap the timeline. Phase 1. Far approach. The object is red, stable, non-fading, shielded by a thick layer of organic tholins. Phase 2. Perihelion heating. The shield breaches. The object turns green. It releases a specific, high-intensity cloud of nickel and cyanide, maintaining a fixed orientation against the solar wind. Phase 3. Departure and acceleration. The object turns blue. It dumps its water-free, carbon-rich fuel, generating massive non-gravitational thrust exactly when it needs to escape the solar gravity well. So, what does this actually mean? If we look at this through the lens of natural selection, cosmic natural selection that is, we are asked to believe in a Goldilocks object. We need an object that formed in a star system rich in carbon but poor in oxygen to explain the lack of water and abundance of C2CN. It needs to have been ejected and traveled for billions of years, accumulating a perfect uniform crust of tholins, the red. It needs to have a layered internal structure where the nickel and cyanides are concentrated just below the crust, ready to sublime at the exact temperatures found at 1 AU, the green. And finally, it needs a core of frozen carbon dioxide and monoxide that triggers only after the outer layers are stripped, providing the blue thrust. Is it possible? Yes. The universe is infinite. Given enough time, even the most unlikely chemical layer cake can form. This is the wild chemistry hypothesis that the majority of the scientific community is currently clinging to. They argue that 3i Atlas is simply a rare specimen, a unicorn comet, that happens to have the most exotic composition we have ever seen. But there is another view, a view that is gaining traction in the hushed corridors of astrophysics departments and the encrypted channels of SETI researchers. The sequence, red, green, blue, mirrors the energy states of the object. Low energy, red reflection; medium energy, green fluorescence; high energy, blue ionization. It also mirrors the functional stages of a probe. Stage 1. Protection. The red tholin layer is an excellent shield against micrometeoroids and cosmic radiation. It's a heat shield. Stage 2. Activation. The green phase, with its specific spectral lines and fixed anti-tail, looks like a system waking up, perhaps sampling the local environment or calibrating sensors. The toxic elements could be byproducts of an internal power source coming online. Stage 3. Propulsion. The blue phase is the burn. The acceleration confirms this. The object is leaving. The signal hypothesis takes this one step further. What if the colors aren't just byproducts? What if they are the message? In our own technology, RGB, red, green, blue, is the basis of visual communication. It is how we encode images. It is how we display data. For an interstellar object to cycle through these three specific bands of the visible spectrum in order of increasing frequency is a coincidence that strains the limits of probability. It is too perfect. It looks like a beacon, a lighthouse sweeping across the galaxy, flashing a sequence that any intelligent observer would recognize as artificial or at least highly anomalous. The skeptics point out that aliens wouldn't use human color theory, and they are right. But physics is universal. The wavelengths of light corresponding to these colors are distinct physical properties. Red is low frequency, blue is high frequency. A progression from low to high is a universal sign of increasing energy. Furthermore, the camouflage aspect we touched on earlier seems to have inverted. If the red phase was a disguise, the blue phase is a reveal. The object is no longer hiding. It is glowing brighter than it has any right to. It is drawing attention to itself. This brings us to the artificial debate. We are stuck between two improbabilities. Improbability A, a natural rock formed with a perfect, distinct, three-layer chemical structure that mimics a technological startup sequence and accelerates like a rocket. Improbability B, an artificial object is passing through our system, and its waste heat or exhaust plumes happen to look like cometary spectra. The data from the blue burst has tipped the scales for many. The lack of water is the smoking gun. Life as we know it needs water, but machines do not. Machines need energy, they need carbon, they need metals. 3i Atlas is rich in carbon, rich in metals, and dry as a bone. It looks less like a biological precursor and more like a technological artifact. As we stand on the precipice of the December 19th approach, the debate is no longer academic. It is immediate. The object is closing in. We have one final window of observation. The impossible sequence is nearly complete. But usually, after the engine burn, there is a coasting phase, or a maneuver. We are about to find out if the script has a fourth act. Proceeding to the final file, we will look ahead to the next few days. The December 19th approach is our last chance to unmask this visitor before it vanishes into the dark. Will we get a radio signal, a radar ping, or just the silent blue ghost of a ship passing in the night? The unmasking is at hand. We are now in the final countdown. On December 19th, 2025, 3i Atlas will reach its point of closest approach to Earth. It won't hit us. It will pass safely at a distance of about 0.8 astronomical units, roughly the distance from here to the Sun. But in astronomical terms, that is a near miss. It is a front row seat to the greatest show in the solar system. This is the unmasking. For the past 6 months, we have watched this object strip-tease its way across the sky. It shed its red coat. It burned off its green skin. It ignited its blue engines. Now, as it swings past us, we have the entire arsenal of planetary science pointed at it. The James Webb Space Telescope is tracking it. The Very Large Telescope in Chile is locked on. Radio telescopes from the Breakthrough Listen project are scanning every frequency band, listening for a whisper, a ping, a carrier wave, anything that sounds like math instead of static. So far, the radio silence has been deafening, but that doesn't mean it's quiet. The blue burst is still ongoing, but astronomers are predicting one final twist. As the object moves away from the Sun and passes Earth, the viewing angle will change again. We will be looking down the throat of the exhaust plume, if that is indeed what it is. This unique perspective might allow us to see the nucleus directly, peering through the thinning coma. If there is a solid, metallic structure beneath that gas, this is the week we will see the glint. There is a palpable tension in the scientific community. We all remember Oumuamua. We remember how it tumbled past us, mute and mysterious, leaving us with more questions than answers. We remember the frustration of not having a probe ready to intercept it. With 3i Atlas, we are once again watching from the sidelines. We don't have a mission on the pad fast enough to catch a hyperbolic object moving at these speeds. We are forced to be voyeurs. But the legacy of 3i Atlas is already secured. Whether it is a natural object with wild chemistry or an artificial probe with a perfect disguise, it has shattered our assumptions. It has taught us that the interstellar medium is not just filled with dead rocks. It is filled with active objects, objects that evolve, objects that react. If it is natural, it forces us to rewrite the textbooks on planetary formation. It means that somewhere out there, there are star systems that produce carbon-nickel cyanide snowballs that act like rockets. It means the galaxy is far more chemically diverse than we imagined. If it is artificial, well, that changes everything. It means the red-green-blue sequence was a greeting, or a scan. It means we have been visited, scanned, and ignored. The acceleration suggests it has no interest in stopping. It is a traveler passing through a small, uninteresting system on its way to somewhere more important. As 3i Atlas fades into the dark, heading back out into the interstellar void, it leaves us with the anomaly of the century. It was the chameleon comet, the shapeshifter, the traffic light in the sky. We will continue to analyze the data for years. The spectra collected this week will be the subject of PhD theses for the next decade. But for now, all we can do is watch the blue light fade. If you found this deep dive into the cosmic unknown fascinating, please leave a like on this video. It helps us bring more of these complex scientific mysteries to light. And keep your eyes on the sky. The universe is getting crowded, and Three-Eye Atlas might just be the first of many. This concludes our report. Good day and good luck.